Wodehouse. I am the volunteer coordinator for Cornell Cooperative Extension Marine Program. And I'm part of an organization within the organization called Back to the Bays. And what we do is we support all of the efforts of Cornell Marine Program to do habitat restoration, population monitoring like seahorses and horseshoe crabs, and aquaculture to help restore species of clams and oysters and other shellfish to our waters. So this is part of our lecture series that we've been having here every first Tuesday of the month. There's going to be definitely one in November and hopefully as well in December, and we're hoping that we can keep this going. So thank you guys for all coming. Today you guys are going to hear from two of our eelgrass specialists, Steve Schott and Kim Manzo. Steve is going to talk first, and they're going to introduce themselves a little bit more. And they'll be around after for questions as well. I will also be around, so if any of you are interested in getting more involved with our Back to the Bays program, we do have a membership that helps support all of our work. It's $25 to join for the rest of the year, and we would really appreciate that. We also have a lot of information up here, so don't forget to check that out and take all the handouts that you need. All right, so Steve, if you want to take it away.
Sure. Hi everyone, my name is Steve Schott. I'm Cornell's Marine Botany Habitat Restoration Specialist. My background is with plants specifically, and even more specifically, marine plants. So I've been working for Cornell for going on 23 years with this job. And the types of things that we deal with besides eelgrass. If you came to our talk earlier in the spring, I talked about living shorelines, working with native plants and native materials. And now this time of year, I'm also starting to get into working with seaweeds and seaweed aquaculture. So today we're going to talk to you about eelgrass meadows, and I'm going to be covering eelgrass ecology and what the current status of eelgrass is on Long Island, and then Kim's going to pick up and talk about our efforts to restore eelgrass and how the community can get involved. So what are seagrasses? So they are actually higher plants, even though they live underwater, much like seaweeds. They are not. They're also not actually grasses. They evolved separately. They do pollinate and produce seeds entirely underwater, so their entire life history is submerged. This is important because there are some people that call eelgrass, or use the term eelgrass for marsh plants that are intertidal. So things like cordgrass and some of the others that you find in the tidal marshes. So eelgrass is a true seagrass and grows entirely submerged. They anchor to the bottom with roots and rhizomes. The rhizomes are very much like your irises that you would have in your gardens. They're underground stems that the roots come out from and support the above ground aspects of the plant, and they act as storage of food for the plants during either dormancy, winter months, which eelgrass doesn't really have a winter dormancy, but it can use that for periods of poor conditions, such as we've had brown tide in the Peconics and other places in Long Island waters. The plants can get through a couple months worth of that with the stored reserves in the rhizomes. Typically found from brackish waters, so really we see eelgrass someplace in 15 parts per thousand up to full strength seawater up over 30 parts per thousand. And worldwide there's 72 species. So again, just to distinguish, seaweeds, not higher plants, don't have roots, stems, rhizomes, don't flower. And then you have our intertidal marsh grasses. They're distantly related to seagrasses, but these grow intertidally and they don't inhabit the same areas. All are important. So just quickly how plants evolved. Even though eelgrass, we think of life coming out of the ocean, you would think that eelgrass would have been an early evolutionary step in plants. It's actually a new evolutionary step. So we started off with single cell algae. Even before that, chemosynthetic or autotrophic bacteria. they got together at some point and created multicellular algae. One of the green algae got a little overachieving and decided to jump up on land with your charophytes and some others. Then we evolve into your land plants, your trees, your grasses, your forbs and things like that. And then some plants decided in more recent times that they wanted to go back to the ocean. You get your plants that evolved back into intertidal plants, like our salt marsh species, and then also things like mangroves. And then you have the seagrasses entirely moved back into the ocean. And again, relatively recently. So this is a new evolutionary step. Seagrasses are temperate. That means that they grow outside of above the tropics in cooler waters. And our species, Oscara marina, only grows in the northern hemisphere. And with global climate change, a lot of these southern ranges have actually started to move up, especially on the east coast of the US. We're one of the fastest areas in the world with water temperatures increasing compared to other areas. In some cases up to twice as fast, which means that eelgrass, which is very sensitive to hot temperatures, is really starting to see a northern push in migration. So this is what eelgrass looks like if you've never seen it. If you really want to see a nice example, go to Cedar Beach County Park, and there's a bunch of it washed up on the beach right now from the storms. Most of it won't have roots and rhizomes. It's mostly just the leaves, but there are some that have washed out fully intact. So again, you got your rhizomes. These are underground stems. They're horizontal, usually laying just underneath the sediment surface. And at each of these segments called nodes, you have your roots will be formed and spread out. And the plant is generally growing as it grows. It would have started over here as a seed. It's growing away from where it started. So it's constantly pushing away from its origin point. And at certain nodes, you'll have shoots that come up that hold your leaves that do all the photosynthesis. And the meristem is just at the base of the leaves. This is a very important part of the plant. That if that meristem, if conditions aren't right to support that meristem and the tissue that is housed in the meristem, the plants die. The life history of eelgrass is pretty important, and for us doing restoration, understanding it makes it very easy for us to plan our restoration activities and monitoring activities and understand what we expect to see at different times of the year. So in general, there's these temperature points you'll see on both sides correspond. So 20 degrees centigrade and 10 degrees centigrade. So that's 50 degrees and 68 degrees Fahrenheit. These are key temperature points. So right now, water temperature, we're in the fall here, and the water temperature is dropping through 20s. We're still above 20, 68 degrees on the water right now. Some of the back bays are a little cooler, but we're coming up on this 10 degrees. And that's an important time because eelgrass generated seeds back in the early summer. It released those seeds worked into the bottom, but they sit there dormant during the heat of the summer. As the water temperature drops down through 10 degrees, 50 degrees Fahrenheit, those seeds are induced to germinate. So they're germinating this time of year, and those seedlings grow throughout the winter. We've tracked seedling growth rates of 1/8 of an inch a day, blade extension. So they can put on, even with water temperatures in the upper 30s, in the wintertime, can actually put on some phenomenal growth to get established before the spring and summer. We say dormancy. The adult shoots are typically dormant. They're very slow growing. A lot of that has to do, anyone who has any understanding of chemistry, if you chill things, reactions slow down. That's the same thing in our bodies. If you cool us down enough, everything in our body slows down. Same thing's happening with eelgrass. It doesn't stop photosynthesizing and respiring. Its whole metabolism slows to a slow crawl. It's still growing, it's still sloughing leaves, it's still producing food, but it doesn't visibly do much. Water temperature warms up again through 50 degrees. Now the plants are generating a flower shoot. So that 50 degrees with the water temperature warming, on the one end tells the seeds to germinate. On the spring side, it's actually telling the plant to actually put up flowers and produce those seeds. Again, typically as we're going through by June, July, in the eastern parts of of Long Island, eastern Long Island Sound, and eastern Gardeners Bay, we can have seed generation into early August. In the middle of the summer, plants like it cold. Eelgrass is more of a cold tolerant plant. So if you're in the South Shore estuary, anyone who's been down there in the canals or the marinas, you see a lot of eelgrass blades getting washed in. A lot of people complain. It's a nuisance. Those plants are sloughing those leaves off, and in some cases that's a response for the plant to high temperatures. It basically helps the plants cope with a hot temperature by getting rid of extra leaves. And then we go back into the cycle and we're back into the fall. So this is really important for us. So if we're doing seed-based eelgrass restoration, we have to be very mindful of when seeds are being released, because we want to collect them and not miss that window. And it's only really a 4-week window that seeds are releasing, with the second and third weeks being the prime yield of seed release. So for us to be efficient, we have to be on top of when that's happening, and not only when, but when it's happening over a broad range of areas. So we start around July 4th and we end in August, depending on what our projects are and our needs are. And then we get into the fall. We want the plants to be out of a period where they're heat stressed. So we typically will not start planting adult shoots in the fall until the end of September, and then we can plant right into December. Those plants don't feel the heat stress and they're not really stressed by cold. So it's a better time for us to plant adult shoots instead of trying to plant them here in a lot of the bays where it gets hot quick in the summer, where not only they stress from being transplanted, but then they get automatically hit with this hot water and further stresses them. So we have better success with working with the seeds in the early summer, and then working with the adult shoots in the fall. So why is eelgrass important? A lot of people hear things about eelgrass. We don't see it very often, at least not as much as we used to. We've lost significant amounts of eelgrass. So out of sight, out of mind. So people really don't think about it. But if you put it in terms of some of the things that are valuable to us that eelgrass provides, then it becomes, the value is definitely more apparent. I like to always put food first, because food usually entices people. So really, eelgrass meadows and seagrass meadows globally are some of the best nursery areas for not only shellfish. We think of eelgrass and scallops, but finfish as well, and other species. We get crustaceans like certain species of shrimp, spiny lobsters, things like that in other areas of the world are very reliant on eelgrass as a nursery habitat, as well as a foraging ground or a refuge from predation at all stages. Physically, eelgrass is a great barrier to have between us and the open ocean if you want to protect your shorelines. I gave a talk about living shorelines where I talked about planting intertidal plants to help anchor sediments and knock down wave forces, but this can start offshore with eelgrass meadows. It's anywhere from a full-grown eelgrass meadow this time of year could knock down wave forces by as much as 60% as the waves travel over an eelgrass meadow. So you're significantly reducing the impacts on the shoreline from a major storm. That decreases significantly in the wintertime because eelgrass reverts to a short form because it doesn't want to get beat up by all those storms. So the smaller it is, the less abuse it takes. So there's a trade-off with eelgrass, but at least for our major storm window in the fall, it's providing protection on our shorelines. It goes without, and can't forget the erosion control by trapping particles as well. And we've seen this out in the field. If you walk along an area where it's patchy eelgrass meadows, usually when you step into an eelgrass patch, you're actually stepping up. So they act as snow fences. They really do trap suspended sediments and cause them to accrete. They do the same thing with juvenile shellfish in a lot of cases by slowing the currents. So you get a lot of shellfish that'll settle in eelgrass meadows just because the currents drop out and they settle. So eelgrass is not only knocking down your wave forces, but it's also trapping any of the particles that those waves suspend and try to pull away from the shore and away from areas where they're usable. Eelgrass is a plant. It photosynthesizes, it produces oxygen during the day. At night, it does respire, and as all plants, use oxygen to burn sugars and produce CO2. It's a nice cycle. Involved in that, in many cases, eelgrass produces a lot more oxygen than it consumes in a daily cycle, when it's healthy and under the right circumstances. It also sequesters nutrients. This is a project we're going to be working with New York State Department of State and the South Shore Estuary, called the South Shore Estuary Blue Carbon Initiative, where we've proposed a restoration and monitoring plan for the South Shore Estuary to increase the amount of eelgrass in the estuary, and for the direct reason of sequestering carbon. A concurrent project is being conducted this year and next by Stony Brook to actually determine how much carbon eelgrass in our waters can actually sequester and hold. You can go online and find a lot of numbers. Those are usually global averages for all seagrasses. So to have specific numbers for our area is really important, and it's going to be a great resource to use in the future. And then, of course, biodiversity. You will not see in our local waters an area that has more variety of fish, shellfish, and invertebrates than a seagrass meadow. The structure alone is enough to attract animals, but then you have detritus from the eelgrass as it dies, feeds a part of the food web, and you just see a lot more life. So what's the current status of eelgrass on Long Island? Unfortunately, we are facing a continuing decline in eelgrass throughout not only Long Island and New York, but the world. On average, we've lost 90% of all seagrasses worldwide. And with global climate change, that's actually continuing and accelerating in many areas. It wasn't, some of you may be longtime residents out here, can remember your favorite creek where you used to walk out off the shore and within 2 feet of water, you were in eelgrass and you could go crabbing, you'd see scallops swimming around. If you were lucky and walked in the summertime and there was a bloom of diatoms that are bioluminescent, you'd see your footprints glowing in the eelgrass. I remember that fondly in Halleck Bay and Orient. So there used to be eelgrass everywhere. That's not the case now, and it's hard pressed for us to be able to take people to an accessible eelgrass meadow. Except for the South Shore, Kim's very lucky that she does a lot of her programs out of Tiana Bayside in Hampton Bays. There's eelgrass meadows right off that facility in shallow water that she can access with her groups and do seining, look for seahorses, and just get people hands in and hands on in the eelgrass meadow and give that experience. Over the last century, as I mentioned, we've lost 75 to 90% of the eelgrass. In 2014, the Peconic Estuary, I'll show you on the map following this, but I'll give you the numbers now. We had 1930, we had about 10,000 to 12,000 acres of eelgrass in the Peconic Estuary. In 2014's, which is the most recent survey, they're looking to do a new survey next year. We had less than 1,000 acres left. So in less than 100 years, we've lost over 90% of our eelgrass. The same thing can be said for Long Island Sound and the South Shore Estuary. The South Shore Estuary in 2002 had almost 20,000 acres of eelgrass. In a survey in 2018, they were down to around 10,000. So they lost half in 20 years. And now in Long Island Sound, there's no eelgrass really west of Clinton Harbor in Connecticut. So where there used to be abundant eelgrass meadows all along the Connecticut shore. Worldwide, this is a problem for all seagrasses. This is not just our problem. And worldwide, the same issues seem to be causing the declines. So if we don't start doing something about this, we could lose this species, especially on Long Island with warming temperatures, because eelgrass is especially susceptible to hot water in the summertime. And that would be a tremendous loss to not only the ecology of Long Island, but also the economy of Long Island. So we'll talk about what can be done with restoration projects. So I'm not gonna spend a lot on this, but here's the graphic. So the mouth of the Peconic River, Montauk and Orient Point. So that bright green is where all the eelgrass meadows were. I was able to map those off of 1930 aerial photos and use Bayman testimony. I'm sure there's eelgrass missing here. It's kind of strange to me that there's none there, but I was working with 1930 aerials. You get what you get, and you can't necessarily find people that can corroborate. But you can see where the red is superimposed. Those are our remaining eelgrass meadows. And this is from 2014. We've actually lost more of that since then. So it's definitely been a dramatic decline for us. And that's just one of our estuaries. So what caused the eelgrass decline? Well, starting in the 1930s, that was a major hit. We lost 90% of all the eelgrass on both sides of the Atlantic, the European side as well as the North American side, due to a chronic wasting disease. This is caused by a cellular slime mold. They're not really sure why it all of a sudden became so virulent that it attacked such a broad expanse of the population of eelgrass. What we do know is that the individuals that survived this were resistant to the wasting disease, but not immune. So while their ancestors, or the eelgrass we have now, they have an innate resistance to wasting disease. Just like any kind of disease, we see the seasonal flu, that wasting disease could mutate and become virulent again in our populations. We do see wasting disease in our meadows regularly. Typically, it's not a problem. Usually we see it on old blades that are starting to decompose, but if you stress a population and you stress the plants, just like if you stress a human, your immune system drops and you become susceptible. So it's not, even though it's an old problem, it's not a problem that we can ignore. Navigational dredging was a big one. Out here, a lot of the creeks were undredged back before 1960. They were relatively shallow in the middles, but those were the deepest parts at the time. That's where the eelgrass was in all the creeks. We started having development out here. People wanted their boats in there, right off their houses and docks that crossed the marsh. So they needed to start dredging. And of course, they're going to dredge the deepest parts because that's the least amount of work. That's where the eelgrass was. There were no protections. So you had bucket dredges out there digging up huge swaths of eelgrass meadow and dumping it up on beaches and just letting it die. Now the resulting channels are too deep to support eelgrass, so the eelgrass can't come back in. And that's been the situation in many of our creeks to this day. Now we get into more present times, the brown tide in the 80s and in the 90s. That had a devastating toll on a lot of the eelgrass, especially in the western half of the estuary, in the Peconics. And it's now having a toll on the eelgrass in the South Shore estuary, where it's almost chronic. Brown tide is almost every year for a lot of Great South Bay. And we've dove recently where it's in 5 feet of water. If you're on the bottom, it's like it's nighttime. That's how dense these blooms are. So if it's that dark for us, the eelgrass is not receiving enough light at depth to survive for most of the year. Coastal development, things like bulkheading, have been found more and more recently to impact eelgrass. So a study done in the Peconics by a grad student from Stony Brook found that eelgrass, the further eelgrass is from a hardened shoreline like a bulkhead or a rock wall, the more likely it is to be healthy and surviving. The closer one of those structures is, those meadows are usually in decline or lost already. Water quality, our big thing is nitrogen. We're trying to address that. The problem is that horse got out of the barn and got way ahead of us. So even if we were to stop all septic on Long Island, which is the major source, just because of the nitrogen in groundwater, in some areas it would take 100 years for all of that nitrogen in those plumes to clear the system. The one thing we could do is mitigate other factors that are impacting eelgrass and let it deal with the nitrogen aspect, which is mostly a problem with competition with macroalgae and also harmful algal blooms. Another big problem we've had, not so much because there's not so much eelgrass, but a lot of people like to boat in shallow waters and also shellfish, mostly recreational shellfishing. Most commercial guys do not want to have to clear a bull rake full of eelgrass to get their clams. But most recreational people, especially if you're out here in the summer or casual, you don't do it a lot, you don't know any better. That, it's easier to dig in a nice sandy area versus digging in an eelgrass meadow. Unfortunately, New York has no laws on the books protecting eelgrass from these kind of activities. The only township that has a law protecting eelgrass from shellfishing activities is Southampton, and that's pretty limited. And then, of course, climate change. So things that we could do to protect eelgrass, improving water quality in some ways seems like an insurmountable task, but if you pick your battles, there are certain smaller water bodies that we can affect more efficiently. They've found in Connecticut and some other areas that if you can get rid of or close off combined sewer overflows and things like that that are leading to especially small embayments, you can improve water quality, and they've actually seen eelgrass regenerate on its own. Avoid any kind of direct impacts. Try not to run your boats outside of navigational channels in shallows. It happens a lot in the South Shore because those channels are crazy and it's shallow everywhere outside of a channel. But know where you're going. If you clam or shellfish, try to avoid eelgrass meadows. Responsible coastal development, I would like to think that we're trying to do better with that. There is a push now with the living shorelines to soften our shorelines. It's still in its infancy as far as how well it's caught on with the public and with regulators, but I think it's getting there. And quite honestly, we've pretty much developed almost all of our shoreline already, so hopefully we can't impact it too much more with new building, but where there's a will, there's a way. Again, just use channels, avoid damaging eelgrass and activities. Down south, there are signs up in Florida that tell you where the eelgrass meadow is, and they will fine you and charge you if they catch you putting a prop scar or running your boat aground to replace the seagrass that you damage. I would love to see that in New York, but we're not at that point yet. And then support any kind of actions to address environment and climate change, and volunteer to help with projects that we do and other people do. I think, yep, that's it. I will pass the torch to Kim.
Hey guys. All right, so I'm Kim Manzo. I'm just going to kind of take over with more of the what is going on right now with eelgrass restoration, the projects we have going on, and the methods that we use to restore grass, and how people can get involved in helping us. So just in general, these are sort of the things that we have learned over the years for how to have a successful eelgrass restoration project. We've had a lot of trial and error over the past 20 years or so, and we've learned a lot. Of course, the most important things are the parameters that eelgrass relies on, which is cool water and light. So of course water quality affects the light that's coming down, and also sediment type. So these are all things that when we are looking for a restoration site, we like to study these things first before we even get involved into the next steps of trying to plant. So we'll put out temperature loggers, light loggers. Sometimes we'll take sediment samples if we believe the sediment might be too mucky. Eelgrass tends to like, sandier sediments, but we have other methods for different sediment types. Of course, we want to start with healthy transplant stock. We like to collect from local meadows. Ideally, we collect near where our restoration site is going to be, with the idea that those plants are adapted to those environmental conditions, and hopefully we'll have, they'll be able to acclimate really well once they're transplanted. Of course, time of year is important. That graphic that Steve showed earlier, that how basically all of our restoration activities have to do with the cycle of the plant, and those two temperatures, the 10 degrees C and the 20 degrees C, are really critical for the growth periods of the plant. So we don't want to be planting when it's going to be too warm, too soon, and the plants are going to become stressed. We want to make sure all conditions are ideal before we put plants in the ground. And of course, we have to anchor the plants down in the bottom somehow. So I'm going to get into that in the next slide, all the different ways we've tried planting grass and different anchoring methods. So other considerations for anchoring. It has to be something inexpensive, of course. You know, we're a non-for-profit relying on grants and small donations of money to try to do this work. So everything we could do economically is important. Not too labor intensive, of course. And not susceptible to bioturbation or erosion. I'll get into that in the next slide too. And ideally, we don't have to follow up and remove anything after we've gone and planted. All we have to do is go and monitor and look at the plants. We don't have to take out any hard structures or anything like that. All right, so basically, there are two ways that we can restore eelgrass. We could restore using seeds, and we can restore using adult shoots. So the seed method, as Steve mentioned, eelgrass flowers in the summering months, right? So those flower shoots produce seeds. We monitor that very closely depending on the different estuaries. So between June and August is when we collect flower shoots. When we first started, we would actually just process those seeds and broadcast them out into a restoration area right off the boat. But we've also developed a method called buoy deployed seeding, which means we actually just harvest flower shoots and we stuff them into these nets here called pearl nets. They're used in aquaculture. And they get to go right out to the restoration site and naturally rain seeds down as they finish developing. The seeds sink down to the bottom, so we can create big grids of these buoy systems, which that is a method we still do use today. But for adult shoots, this was one of our older methods we used to use, the turf method. This was developed up in New Hampshire, Fred Short. So we would actually use, it was like lobster pot material in a frame that we would actually use like tissue paper, very soft paper, and tie the grass to the bottom of that frame and put it down in the bottom with the idea that that tissue is going to dissolve away, and then the plants will take root, and all we have to do is go and take those frames away in a few weeks. Back to that last slide, I mentioned we don't want to do things that bioturbation, meaning that brings in a lot of animals. So animals loving it to death, basically, bioturbation. We have a lot of creatures, such as crabs and things, that get attracted to all this structure, and then they end up digging up our grass. So that wasn't such a good thing. Plus, it's a lot of work hauling these big frames in and out of the boat and things like that. So we got away from that method. And then we got into doing more just free planting. So this was literally just taking one shoot of eelgrass at a time and pushing it into the bottom. That's free planting. So labor intensive. And after free planting, we were looking to do more work out in Long Island Sound, and there really wasn't a lot of these sandy areas. But all the other conditions were ideal for grass. It was nice and cool and clear water. There was already existing eelgrass meadows nearby. So we started just taking some handfuls of plants and kind of using a rock as an anchor and just going along in these rocky habitats and planting eelgrass that way. And actually, we were extremely successful. We have a site out in East Marion, St. Thomas Point, which is our largest, most successful eelgrass restoration site so far, all done using this method. So now this is pretty much our method we use in Long Island Sound now. So this is leading up into our newest method. So with all that success of the rock method, we were like, what do we do in places we don't have rocks, but we like how the rocks anchor, right? They work really well at anchoring. So we started making artificial rocks. So we actually took burlap and made a sack of sand and made these sacks that we called artificial rocks and used those to weigh down the plants. And it worked pretty well, but unfortunately, when storms and things came through, these artificial rocks actually caused a lot of issues with erosion. And after a lot of trial and error, we even tried burying those artificial rocks a little bit, and then we realized we don't even need those anymore. We just need to bury the grass. Basically, a new method of planting eelgrass was born. All right, it's known as the biodegradable disc method. We lovingly call the tortilla method, and that's because it looks like kind of like a tortilla. So the advantages of the tortilla method, there's a lot less bottom time for us divers now. We're planting 10 shoots at a time rather than 1 shoot at a time. It has drastically increased the amount of grass that we can get into the bottom, therefore, and the scale of the plantings that we can do. So we can do such a larger area than we used to be able to do in the same time period. Happy divers, meaning that, like we mentioned before with our whole temperature chart, we're planting in the fall months. Really, October, November is our planting window. So if we can be done planting early November, we're much happier. Once we get into late November, December, we get cranky. And of course, this opened up a whole new way for us to have a public outreach component of our eelgrass restoration work. And that is when the Marine Meadows program was born. What this method entails is we create these discs of burlap here that we use to weave the eelgrass into. And we actually had a shop class help us come up with a press for making these burlap discs. So we have a lot of students help us to make these throughout the year. And then, so this can be done, like I said, throughout the year when it's not the fall when we're planting, right? So we can stockpile lots of these tortillas and be ready for our restoration projects. And what we do is when it's a workshop day, you're going to weave the eelgrass through the outer hole and back up through the inner hole so that it looks sort of like that when you're done, and you have, it's kind of like a pinwheel at the end. So when we go out to plant these, after we've done all those preliminary observations, making sure, temperature, light isn't going to be an issue, whether there was historic eelgrass in that area, all that homework. We've done our homework already. Now we want to do a test planting. So we'll usually start with smaller test plots. Between 10 and even up to 30 would be a test plot for us. And when we come back to that spot, if that spot was successful, then we scale up and we start doing more and more, and we'll do 50 to 100 per diver at those locations. So basically, here's the components of what we use when we're planting. I brought my tools here. So if this was loaded up with eelgrass, as a diver, what we would do is we would take our ring here and push it down into the sand. And we use our fancy shovels here. These are our favorite shovels. We like using these big clamshells. This way, we don't feel bad if, they don't float away on us. And then if we lose it, we don't feel bad that we're littering on the bottom either. So that's another thing. So we use these to scoop sand out, level it back out. We pop the eelgrass into there, put sand back on top, and we just pull this away. And that's when you're left with that individual planting. And we just go along and do rows and rows and rows of these. Often, there's 2 or 3 of us doing this, so we'll work side by side. And just create this big grid. So the different phases. People ask us, where do you get your eelgrass from? I mentioned before, we try to collect from healthy meadows. We do it in a sustainable way. We try to collect only 1 shoot per square meter or so as we're diving and collecting so that we're not impacting that meadow. We also, after we collect those shoots, we have to make sure that they stay healthy until we have our workshops. So in Southold, we have flowing seawater tanks, and that's why we wait until the water is cool enough for this, because even during holding all these shoots and everything, we have to keep the plants cool and happy. And then workshop day. So this is when we get the public involved in helping us weave the grass. So I'm going to get into that a little bit more after. And soon after the workshop, as soon as we have the good day to get out on the boat and do our planting, we go out and do our eelgrass planting. And following that, we try to go back every few months to monitor, or at least the following spring. If it was done in the late fall, we go first thing in the spring and try to monitor those plantings, see how they did throughout the winter. All right, so this is basically after a Marine Meadows workshop, we end up with coolers full of these beautiful pinwheels of eelgrass. So this is what they look like, and then this is us getting ready to take them down. We put them on these, I don't know if I had it. I brought a skewer, but we put about 50 or so of these loaded tortillas per skewer per diver. Sometimes each diver is doing 50 to 100 or more per dive. And I kind of showed you this already with my little demonstration, but this is how we plant them. No, this was a very shallow spot in Moriches Bay, close to the inlet. We can stand, yeah. Very often where we're planting, we can stand up. You know, eelgrass in our region, in this area, especially down in the South Shore, grows pretty shallow. The South Shore is very shallow in general. So it can grow in 2 feet of water to, you know, maybe 5 feet of water, I'd say would be probably the average down in the South Shore estuary. The Peconics, it's usually a little bit deeper than that. But it can't grow deeper than where it gets enough light, so that's the whole. So then, these are just monitoring pictures. We like to go follow up at those planting areas and see how they're doing. Sometimes we find cool things like squid eggs on our plants. We find lots of animals utilizing it already. Sometimes we see incredible growth, and then other times we see minimal growth. So these are all things that we have an archive of thousands of photos and videos that we're constantly just trying to keep track of. You know, if this planting failed, what was the reason? We need to try to stay on top of it so that we know how to be successful next time. All right, so in the fall, usually October, sometimes November, we have these workshops that people can come help us to weave the grass. We've had them hosted at a lot of different places, restaurants, you know, besides our facilities. Restaurants, environmental organizations, even parks and other town facilities. And then you can see here, these are kind of just the activities that go on at a workshop. We usually start off, this is Hazel here giving a little introduction about why eelgrass is important, all the benefits of eelgrass, you know, before people get started. Definitely, we want to make sure that learning component is there. And then we just get hands-on with people, and we are happy to just, you know, be sowing our grass and chit-chatting and seeing why people are there or how they heard about us, and, you know, if they want to get involved in other things with us as well. So it's just a great opportunity for us to connect with people of similar interests and who want to help the environment. All right, so I popped this in just because one of the key components to this program is the fact that we do have our Marine Center in Southold, that we have these large flowing seawater tanks, because as you saw step by step, we need to be able to collect these shoots and hold them, and then we need to be able to hold these planting units until we can get out and plant them. It's always like we do it as fast as we possibly can, but of course, weather is a huge thing, and as you guys have known from just the weather the past week or so, you know, the fall can be really difficult for us to get out and find a nice calm day that's not windy, that we could take the boat out and go plant. So we have to baby these things up until that perfect day comes that we can go plant them. And I mentioned before, in the off season, I work with a lot of school groups and just other, you know, people wanting to get involved. I actually had a teacher present at a Sea Grant conference this past weekend about making tortillas in classrooms, and I now have 3 or 4 teachers emailing me wanting to do that in their classroom this fall. So yeah, it's just a really fun way to kind of get kids learning about what eelgrass is and doing something hands-on. You know, it's just cutting, and they can make it almost a little competition. It's kind of fun. So we promote our workshops. We usually, you know, create flyers. We do a lot of it on social media. So if you guys are interested in this stuff, please sign up on our email list, and then you'll get emails and notifications about any of these types of things that are going on. But for this fall, we have 2 workshops, and I actually have a handout for you here if you are interested in you know, attending one of those 2 workshops. One of them is going to be right in Cutchogue, October 15th. The other one's in Bellport on October 29th. So yeah, this is just other, you know, informational handouts we like to distribute at our workshops, and also just throughout the year in our youth education different kits and packets and things, just teaching people about marine habitats and eelgrass specifically. And then I also wanted to just mention that Marine Meadows, of course, was founded because of this new method of restoring eelgrass, but we're kind of expanding upon it in that we want to get volunteers to help with other aspects of coastal plant restoration as well. We could use the help with this too. So, and there's also, different things happening throughout the year with different species of coastal plants. So we're starting to work, have workshops of, doing marsh restoration, beach grass restoration, and even this past summer we did a buoy deployed seeding event that we had a few volunteers come out and help us stuff the flower shoots into the nets, and they got to see them get deployed, and so that was really cool. What we have going on currently, you can see right now the yellow little triangles, those are our active restoration sites. Through the funding partners here, NIFWIF is funding all of our Long Island Sound work, and then we have some other projects going on in, Tiana Bayside is funding a whole bunch of different coastal plant restoration, as well as an oyster reef and eelgrass plantings down there. And yeah, and even on this map you can see, I also wanted to mention these are our long-term eelgrass monitoring sites, these blue dots. So not only do we do restoration, but for the Peconic Estuary program, we're doing monitoring of the existing eelgrass meadows annually, just to kind of keep track of any losses or other trends that are happening. And yeah, and there's some other, you can see some past planting locations on this map as well. I wanted to announce that starting next year, we're going to have a 5-year project throughout the entire South Shore Estuary Reserve. I think Steve kind of mentioned it with the blue carbon, right? But we will be doing a lot of test plants of eelgrass. We currently have 50 monitoring stations already set up this fall because we want to know the conditions before we start planting next year. So we want to know where we should put all of our eggs, so to speak. So yeah, this is very exciting work for us. We're going to be very busy, and hopefully we'll be bringing a lot more eelgrass back to the South Shore in the coming years. All right, so mark your calendars. These are our 2 upcoming workshops. I actually have this printed out as a handout, so if you're interested, you come grab one. I mentioned this before. We have one on October 15th, and another on October 29th. And yeah, if you scan the QR code, it'll bring you right to the page where you could sign up. It's free to register. It's just preferred if you do, so we can get an idea of how many tables to bring and just have enough of grass and everything for everybody to participate. I believe that's it. Yeah. I had a little video at the end if anyone was interested. This was kind of a summary of our Marine Meadows program we had done through through National Fish and Wildlife Federation grant a few years ago. So maybe I'll pop that on right now. So